This is 2.2, day 2, part 2. There are two examples. One that I'm going to graph is a cubic function, and the second one I'm going to graph is a quartic function. They're the same steps, just the graphs are going to look a little different. So I recommend you write one of the two examples down in your notes today, and then follow along with the other one. So you choose which one you want to do. So here is a function. It's a cubic. It's not in standard form. So we're going to go ahead and rewrite it in standard form. So you always have the highest term first. So it's negative x cubed minus 5x squared. Then I would like you to try the leading coefficient. If you're writing it down, write it down. If you're thinking it in your head, then you're doing it in your head. The degree is blank, which means it's either even or odd, and the leading coefficient is greater than or less than 0. What does that mean for our end behavior? So what we did yesterday in our lesson. What did you say for the degree? What is the value of the degree? 3. Is it even or odd? Odd. And the leading coefficient, is it positive or negative? It's a negative 1. So what does that mean for my end behavior? What will the graph do on the ends? Do you agree? Rise left and fall right. So maybe we need to go back to our chart from yesterday. So our degree is odd and our leading coefficient is negative. So it's right here. We're rising on the left and falling on the right. Then, from yesterday's lesson, we focused on the zeros, which are the x-intercepts of the graph. And if you can't factor it in a quadratic function, you have to then use a quadratic formula. So we're going to set this function equal to 0. And I'm going to write it in standard form first. Now I'm going to take out the GCF. So I'm going to take out x squared. So I'm left with negative x minus 5. Then I set the functions equal, or the factors equal to 0 and solve for x. So in this case, we're going to square root this answer, and we get that repeated 0 that we told you yesterday. Just don't worry about until today. We'll talk about it. Then over here, negative x equals positive 5. So then x equals negative 5. So then identify the x-intercepts, 0, 0, and negative 5, 0. I'll give you a little bit of time to catch up there. Now we have a repeated 0 with an x squared factor. So look at the k value, the power. Is the power even or odd? Is this even or odd? Even? So if we go back to the rule, right here, since my power is even, it does not cross the x-axis. So let's write that off to the side. All right. Now let's check and see if there's any symmetry. On that last slide set, it helped us a lot to know if there was symmetry about the y-axis. So let's substitute negative into the function. Move down my function again. My function was f of x equals negative x cubed minus 5x squared. So we substitute a negative into the function. And simplify. Negative, negative, negative x becomes a negative x cubed, and then go back and multiply it to a negative, and you get a positive x cubed. And then negative, negative x is a positive x squared. Go back and multiply it to negative 5. You get negative 5x squared. We don't get the original function back. We also, if we pull out a negative into the function, out of the function, we also don't get the original function with a negative. So there's actually no symmetry here. So that's not going to help us. Now before I do step 5, let's just see what we have so far about our graph. So I'm going to start off by graphing the end behavior and the x-intercepts. And then I'm going to find a few additional points to help guide me for the rest of the graph. And then I'm done. I've drawn a sketch. That's not going to be exact. It'll be pretty close. So we have our x-intercept of 0. And then we have another x-intercept at negative 5. So we'll just call this right here, negative 5. All right. Then we talk about our end behavior. What was our end behavior? What happens on the left? We'll talk about negative 5. What happens to the left of negative 5? It rises. There are no more x-intercepts possible. So I cannot go back down. I can't go like this because there's no more x-intercepts to give out. Then, to the right of 0, what happens? It falls. And remember, this is a repeated 0, so can it cross the x-axis? Does not cross the x-axis. The test showed that. So this is my falling. What do you think is going to happen between those two end behaviors? It's going to dip down or it's going to dip up? What do you think? We have to have a shape of a snake, right? Maybe something like that. So then you would plot a few additional points. And how you find those additional points is you're evaluating the function. So let's just plug in a number like negative 2 and see what happens. So we're trying to find out what happens between negative 5 and 0. So we're going to go back up to this part now and evaluate it. I'll finish this problem, then we'll stop this recording. So there's my function. So I say f of negative 2. So I have negative, and then negative 2 cubed minus 5 times negative 2 squared. And then we simplify. Negative 2 times negative 2 times negative 2 is negative 8. Negative 2 times negative 2 is 4. And then multiply. Negative negative turns out to a positive 8. And then negative 20. So we get negative 12. So what is the ordered pair that we just found then? Yep, negative 2, negative 12. So then we can go and graph that. At negative 2, I'm down at negative 12. So what do you think is happening here? Remember, this cannot cross the x-axis. Can't cross it because that repeated 0 is even. So what's going to happen? It's going to come down, and like what you guys were saying was right. And then what's going to happen between negative 2 and 12? It might go down a little further. It's okay. Maybe it comes down a little bit further up. We're not really caring too much. And it has to come back up. It cannot cross the x-axis between 0 and negative 5 because there's no more x-intercepts to give out. And there is our snake. I'm going to stop the recording there, and we'll do one more example.